I've been having a lot of fun making 3D printed Hot Wheels track. I've even 3D printed cars. But in the process, I accidentally made this. It's a collapsible, foldable Hot Wheels track. And I did it all by accident. I'll explain it all on today's Filament Friday. Everything printed in this video is done on the Prusa Core 1 3D printer, which was donated to this channel. Before I get into the details of how I did this folding track and how it happened and kind of fell in my lap, let me give you a history of how I got here in the first place. This is where it all started. I bought this $5 Hot Wheels or off-brand Hot Wheels set at a dollar store because I thought it would be fun for the grandkids, and then I got carried away. I wanted an electronically controlled starting gate, and I ended up designing this for this cheap little set. I did a video on this showing how I did it, and it turned out great. But for right now, I'm happy with the results I'm getting out of this design I made to lift the starting gate, just using Arduino and some code, and then simulated it in Tinkercad circuits, so it goes to a red LED, yellow LED, green LED, and then the servo motor lifts the arm, and the cars are launched down the track. So right now it's still just an Arduino with a breadboard, but it works. Their little fingers can get in there and press the button. They watch the colors change until it goes green, and then the cars go running down the track. They've had a lot of fun with this. Then I set up a much bigger track. On Amazon, I found these wheels and axle sets. You can buy 10 in a package, and they're similar to Hot Wheels axles and tires. So I designed a chassis for them to snap into in Tinkercad. And here's my first one printed on a Prusa Core 1, and it came out really nice. The axle snapped right in place and it rolled perfectly down the track. I printed 3 more in different colors, and now I had a full set of cars to race. But I didn't like this track. I didn't like how it sagged. I didn't like how I had to support everything. I went back to Tinkercad and designed my own straight track, and this is going to be solid. And it's got slots so I can put the normal Hot Wheels connectors in there, but I also added these Stemphy screws. These are screws that can be printed flat. They come with nuts. There's a whole bunch of pieces you can print. And I designed the track to snap over that screw, and plus the connectors that go in those slots, and then I can put a Stemphy nut over that screw to hold everything together. So here's how it works. I printed some connectors. They're Hot Wheels connectors, but they're a little bit shorter. And then it snaps over that screw just like this, nice and tight. I ended up having to print the track standing up to get everything to come out right, and it did. And then all the way down the side of the track, I put those nuts on top of the screws, including the support, and this thing was solid. And as I showed at the beginning, it worked great. Now, I don't like printing standing up like this, especially if you got a bed slinger. It doesn't hold up. And it takes an hour and a half on the Prusa Core 1, which is still pretty fast, but I knew I could go faster if I laid it down. I took almost a half an hour out of it. But that means I needed to redesign it, and I wanted to make it wider. Now, I wanted at least 4 lanes, 3 grandchildren, 1 for Grandpa, and I thought about getting the 6-lane track. I had one in the past, but it got broken, but it's actually a really cool track, but not cheap at all. So I redesigned my track for 4 lanes, but I didn't like how it stood up. And then I got rid of the slots on the bottom, went to a little different design, but that would crack off real easily. So I decided to just start over, change the design, and just go with the screw and nut idea on both ends of the track. But instead of using a 4-hole Stemphy brace, I started out with a 2-hole Stemphy brace, and that didn't work because I could only get 1 nut on. Once I tried to put the second one, there just wasn't enough room. From there, I redesigned it for a 4-hole brace. And then on one end, I put a convex shape where it bumps out. And then on the other end, I put a concave shape. That way these two lock together and line the tracks up. And so then I had my new track, and I could print this laying flat on the Prusa Core 1. And that's what I did. Everything was printed again on the Prusa Core 1. This thing did a great job. Although I did add one thing. My Prusa textured plate was being used on another printer, so I just threw this cryo grip in there. It barely fits, but it did such a good job, I just ended up sticking with it. I kind of forgot it was there. Now this is twice as much track as the 2-lane, and laid down, it saved me a lot of time. At a 0.2 layer height, it took 1 hour and 46 minutes, slightly more than the 2-lane. But when I put it at a 0.28 layer height, which should be fine for what I'm doing here, then it actually brought it down to 1 hour and 34 minutes, the same as standing up a 2-lane track. So I'm saving time and I'm getting a wider track. So I was really happy with this. The auto level works so great on the Prusa Core 1. The first layer is like perfect. Those little screws sticking out of the track came out great. And the bottom surface was nice and smooth and flat, and I got the texture that I wanted. So I printed a whole bunch of them so I could start building my track. And then I just needed to print the 4-hole connectors with the nuts. Now the 4-hole braces that I'm calling connectors were printed at a 0.2 layer height. The nuts I printed at a 0.12, and they came out great. So then I started connecting the tracks together, and that's when the accident happened. When I tightened the nut, the track split like this, and I realized that I could pivot this thing and make a stackable track. Just by taking these in different positions, I could lock them back together because of that concave and convex shape. But I could actually stack these on top of each other or fold them into each other and make a foldable track. So I built a track that's just barely fit on my presentation table that I filmed behind. And the last track, because I could pivot it, I pivoted straight up to stop the cars from falling off the end of the table. So this was working really great. I put T-braces on the end to create the ramp effect, and these could be folded up as well. And then I tried to fold it up, and this is what it did. It actually folded into a stack just like this. I ran out of black filament on one of the tracks, so I just used some gold that I had, and I love the effect. It looks like a starter track. So the next step is to make some kind of starter gate for this thing. So I unfolded it so I could test the starter gate, and I found this just takes practice. Once you get the hang of it, it's not too bad. So I went back to Tinkercad and I designed a hand lift starter gate which blocks the lanes, but connects to 2 Stemphy braces that pivot on the screws that come out of the side of the track. Now if you're wondering how I get all these Stemphy braces into Tinkercad, you just go up here to the drop down below basic shapes. There's a whole bunch of different categories. Click on feature collections, and then at the top you'll see a Stemphy nut. Click on that, and then here's all the Stemphy blocks inside of Tinkercad ready to use. So if you scroll down to more shapes, you'll see a whole bunch more, and then here's the 2-hole that I used previously. You just drag and drop it into your Tinkercad design. It's that easy. I brought all the pieces for the starter gate into Prusa Slicer, and I printed at a 0.2 layer height, and everything looked really good. This is really an easy print. Now I did print the nuts at 0.2 as well. I recommend 0.12, but this only took 42 minutes, and it actually worked great. Here it is in action. This thing pivots very nicely and holds. Nice handle to grab onto. So I just put the cars in their slots, and then when it's ready to race, I just lift the center tab, and away they go. Now everything but the wheels of the cars is 3D printable, including the tool to tighten the nuts. So this is really cool, but this is not original. I did find this after that you can just buy from Hot Wheels a foldable track, just like what I've done. Now it's really, really short, but I gotta admit, I love their finish gate. I'm gonna try and copy this for my own design. There's can add track after the finish gate, but it's kind of meaningless in my opinion. For mine, I can add more track just by printing more and then making the stack taller. And if anything breaks, I can easily 3D print a new section. So that is the advantage of 3D printing. Cost-wise, I probably spent about 2 spools of filament, so that's about $40, so about the same price. I'll put a link to all the parts, including .stl files, in the description below. But if you want the source files from Tinkercad because you want to improve it, that you need to be a Patreon supporter. So join Patreon and have access to that. I want to give a shout out to my Patreon supporters. Without your support, this channel would not be where it's at today. Now next, what I'd like to do is figure out how to do an electronic start gate and also an electronic finish. That's going to be a fun project for the future. Thanks for watching. And here's a few other videos you might like. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that logo and subscribe. I'll see you next time right here at Chuck Hollenbach's Electronic Products and Filament Friday.